Hello, myself Dr.D.K.Shedge, professor in Department of Electronics and Telecommunication Engineering, AISSMS Institute of Information Technology, Pune, Maharashtra. Today I am going to discuss the properties of linear time invariant system from the impulse response. It is said that impulse response completely characterizes the linear time invariant system. That's why if we know the impulse response, then we'll be able to find out the properties of certain properties of the linear time invariant system. These properties are causality, then whether system is static or dynamic, and then stability. Causality, first property, the causality of linear time invariant system. A linear time invariant system is to be called to be causal if the present value of output depends on only present and or the past values of inputs. So output here can be written convolution of x of k with x of n with h of n, or using the commutative property of convolution we can write output as the convolution of h of n with x of n. The same equation can be written here, the convolution of h of n with x of n using the commutative property of convolution as a summation from k equal to minus infinity to plus infinity h of k x of n minus k. Then same equation can be stretched or splitted this summation from k equal to minus infinity to k equal to plus infinity. The negative terms, negative k value terms, h of minus 2 x of n plus 2 h of minus 1 x of n plus 1, right from minus infinity it will come to that. And then 0th value term at k equal to 0, h of 0 x of n, h of 1 x of n minus 1, h of 2 x of n minus 2, and so on. From this equation we'll get very easily that if our this convolution equation includes the terms onwards h of 0 x of n, h of 1 x of n minus 1, h of 2 x of n minus 2, and so on, then system will be causal. Or in other words, if the negative value terms of k are equal to 0, then system will be definitely causal. Or in other words, h of k 0 for k less than 0, then definitely system will be causal. Or otherwise system may be non-causal, including any of the term which indicates that output depends on the future coming values of x of n, like x of n plus 1, x of n plus 2, and so on. This is for discrete. For continuous as well, we'll get the similar condition that h of t should be 0 for t less than 0, then definitely the system will be causal. Second property, system with memory or system without memory. With memory is called as a dynamic system, without memory is called as a static system. A system is called to be memoryless or static system if present value of output depends on only present value of input, then system is said to be memoryless. That can be seen from these two, this equation. X1 Y1 is one of the pair of input output, X2 Y2 another pair of input output, X1 T0, X2 T0, then Y1 also should be T0 and Y2 also should be T0. Means present value of output will be depending on only present value of input. Same thing can be seen from the convolution equation, where convolution equation is written for y of n in terms of x of n and h of n. The y of n equal to x of k, h of n minus summation x of k, h of n minus k from k equal to minus infinity to plus infinity. But here you will get that if you want that output should depend on only present value of input, then the h of n should be k into delta of n. H of n should be k into delta of n, or that will become h of 0 into delta of n, isn't it? For this is the condition for the discrete time system, whereas for analog system or continuous time system, the condition for the system to be static, it will be h of t impulse response to be given by k into delta of t, where k is some constant. Then definitely system will be a static system, memoryless system. If h of n is k into delta of n or h of t is k into delta of t, then and then only the system will be static or memoryless, or otherwise system will be dynamic with memory. Then third property which we can find out only by observation from h of n or h of t is the stability. We know the condition for stability, BIBO stability, bounded input, bounded output stability. If input is bounded, then output also should remain bounded. Then system is called to be a stable system. So we saw in convolution equation, y of n is given as convolution of x of n and h of n, or it can be written as convolution of h of n and x of n. Same equation can be written as y of n is equal to summation from k equal to minus infinity to plus infinity h of k x of n minus k. X of n minus k will be shifted version, so it doesn't alter the bounded input. So input will remain bounded even if it is shifted. So from that convolution you can take outside that value of x of n minus k, and what will decide whether output will remain bounded, it is the only summation from k equal to minus infinity to plus infinity of h of k, mod of h of k. So if that summation is less than infinity, then definitely the system will be a stable system. For bounded input, output also will remain bounded. For continuous time, it will be integration of mod of h of t. It should remain less than infinity, then system will be stable. This equation will be absolutely integrable. System will be BIBO stable. We can see with the help of one of the example of this continuous time system, where h of t, the impulse response of system, is given by a rectangular function rect t upon 10. Rect t upon 10 means it is a rectangular function having a value of 1, and it is having a width of 10. It is centered around 0, so it is existing from minus 5 to plus 5 and with a value of 1. And we are asked to check whether system is causal, system is static or dynamic, and system is stable. First of all, we'll see whether it is a causal. The condition for causality is that h of t should be 0 for t less than 0, but here you are able to see that h of t is having value 1 from minus 5 to plus 5. So minus 5 to 0 won't satisfy the causality property. It is having value 1 from minus 5 to 0. That's why h of t is not 0 for t less than 0, and system is non-causal. Secondly, whether system is static or dynamic. To be static system, it is required that h of t should be k into delta of t. But here h of t is not of that form. That's why system won't be static, system will be dynamic. Thirdly, to find out stability, it is desired that mod of h of t, its integration, should be less than infinity. Here we will find out integration of mod of h of t from minus infinity to plus infinity, but h of t is having value plus 1 and it exists from minus 5 to plus 5, so it will become integration from minus 5 to plus 5 of delta of dt, and the answer will come out to be t. And limits of integration we have to put from minus 5 to plus 5, upper limit plus 5, lower limit minus 5. The answer will come out to be 5 minus minus 5, 10. That is a finite value. It is a value less than infinity. That's why system is stable. Thank you.